Welcome, folks. Today we are discussing a study on estimating mango mass from RGB images using convolutional neural networks. Let's dive in.
I'm eager to hear about this. What's the main problem this research addresses?
Well, mango grading relies heavily on factors like size, color, texture, and mass. While there are many methods for estimating mango mass, like SVM, discriminant analysis, and even Bayesian networks, this study focuses on using a CNN, a convolutional neural network, which is relatively unexplored in this specific application.
So, they're using computer vision to weigh mangoes? That sounds innovative. What kind of results did they achieve?
Exactly. They developed a CNN architecture specifically designed to estimate the mass of Harumanas mangoes from RGB images, and the results were quite promising. They used a dataset of 548 mango images, split into training and validation sets. The trained model achieved a mean squared error, MSE, of 0.02227 and a mean absolute error, MAE, of 0.03697 kilograms. These are pretty low error values, indicating good accuracy.
That's impressive. But how did they make sure the CNN could accurately assess the mass? Did they use any clever tricks?
Yes. A key aspect of their approach was using a blank A4 paper as a visual cue in the images. This provided a consistent scale reference for the mangoes, helping the CNN better understand the size and therefore the mass. They also created a Harumanas mango image and mass dataset for benchmarking, which is a valuable contribution to the field.
I see. So the A4 paper acts as a kind of internal standard for size comparison. That's a smart way to improve accuracy. But are there any limitations to this approach that you can think of?
That's a great point. While the results are promising, the model's accuracy might be limited to Harumanas mangoes. It might not generalize well to other mango varieties with different shapes or textures. Further research would be needed to test its performance on a wider range of mangoes. Also, the lighting conditions during image capture could affect the accuracy.
Absolutely. Real-world conditions are always more complex. But overall, this research seems like a significant step forward in using computer vision for agricultural applications. Thanks for summarizing this interesting study.
You're welcome. It's fascinating to see how CNNs can be applied to such practical problems. Thanks for listening, everyone. Goodbye.